Erin, thank you so much for making this for me. I absolutely love it. Thank you. It's so good. I know.
It's time for Maths with Mr. Thomas.
So here we go with Chapter 7, Lesson number 3, working out the area of a triangle. Ba-ba-ba-bam! I've split this into 2 lessons. In this lesson, we're just really working out the area of a triangle. There's also a couple of harder examples at the end. And in the next lesson, I'm going to give you the area of the triangle. Oh, you're so kind to us. I know. And you'll have to work out the angle or the length of a side. Oh, take that back, you're mean. Well, let's move on with this lesson first anyway. Working out the area of a triangle. You know how to do that, Sam. If anybody's unsure, help them out. Well, you work out the area of a triangle by doing half of the base times by the height. You do indeed, yes, Sam, you do that. But why, Zainab? Why is it half of the base times the perpendicular height?
It's because if you put a rectangle around that, like you're doing there, terribly with the mouse, it's half of that surrounding rectangle.
Yeah, you're perfectly right, because this green part here is half of this whole box here. And this green part here is half of this whole box here, meaning that that whole green triangle, ton ton ton, is half of this surrounding rectangle. And that is something you learned about years and years and years ago. So, if we're moving on then, Leah, the formula that you already know to work out the area of a triangle is
half of the base times the height.
Yeah, very well done. It is half of the base times by the height. However, this is not National 1. This is harder. This is National 5. Instead of something as easy as that with the base and the perpendicular height given, instead you may be given something like this. Ah! I know. Where we are given an angle. Remember, capital letters represent angles and lowercase letters represent sides. Well done, you watched that last video. I'm impressed. So let's say we have 2 sides, just calling them A and B, and we've got this angle here, we're going to call that C. So how would you work out the area of this triangle where the perpendicular height is not given? Dun dun dun! Just a side note, for anybody that is quite geeky, Marley, you may wish to look through the rest of this slide. If anybody's not that geeky, Scott, you might just want to move on to the next slide where it is given, because you don't really need to know where this comes from. You just need to know what the formula is, and I just showed you it there. Oh, a wee sneak peek. But if you're wanting to work this out anyway, for the geeky people amongst you, let's try this. What could you do?
Well, I would think you would have to work out the perpendicular height first of all.
Brian, you're right. You could always do that. And how could you do that, Brian?
Well, if you took that triangle on the left, you could use SOHCAHTOA.
Yeah, you could indeed. Yeah, you could work out the vertical height by using SOHCAHTOA. Whoops. There we go. So, if we know this angle and we know this side and we know B, well remember B goes from one side right the way along here to the other side here. So we couldn't really use B, but if we've got this angle and this side, that there would be a right angle if it's a perpendicular height, meaning we would have the good. It is the hypotenuse. So we'd have the hypotenuse and we'd be wanting to work out this opposite here. And that is the opposite. Just very, very quickly then, we would have H, we would have O, but it is the sine x equals opposite over hypotenuse that we want to use. It is the length of the opposite that we would be wanting to find, and because these letters are beside one another, S and H, we would times them. So really, the perpendicular height would be given by the H, which is the hypotenuse, which is A, multiplied by S, which is the sine of the angle. So it'll be A times sine C. But what you want to do is you want to think back to that other formula. Wally, what's the other formula?
A half of the base times the height.
It is indeed, yes. Half of the base times the height. But the height, remember, we didn't know.
But we do know it now. It's A times sine C.
Good. So you can say the area is half of the base. So it's a half times B times by A times sine C. Woo! And if you rearrange this, you can work out the area of any triangle when you've got two sides and an angle between them by using this formula. Woo! Geeky people, didn't you love that?
Yes, we did.
But for those of you that were not geeky, that went on to this bit, if you know two sides and the angle between them, the angle between them is known as
It's the included angle.
It is indeed. It's the included angle. It's the angle between the two sides. You can work out the area of any triangle using this formula. Area equals a half times A times B times sine C, where A and B are the sides
Because they're lowercase letters.
That's good. And sine C, C is
The angle.
It is good. C is the angle.
Because it's a capital letter.
Very well done. Good. So the area equals a half AB sine C. Woo! Shall we try some examples with that?
Yes, please.
Okay. Example 1. Calculate the area of this triangle. So once again, we've got two sides and the angle between them. I'm not going to start putting in A, B and C or A, B and C or thinking about where the letters would go, because all you have to do for this, if you've got two sides and the angle between them really has to be C, meaning the other sides will be A and B, but it doesn't matter which is which. It's just two sides and the angle between them. So the formula area equals a half AB sine C. You will need to remember that. Well, not really, it's on the formula sheet. But if you remember that, it makes it slightly quicker for you. So you've got a half times A times B times sine C. So it's going to be a half times by, what are A and B? Good, it's the 14 and the 18, and it doesn't matter which way around you have them. You could do the 14 times 18 or 18 times 14. You get the same answer, so it doesn't matter which way around you have them. And you're multiplying that by sine C. And C is the angle. And the angle is 30 degrees, so it's going to be multiplied by sine 30. If you stick that into your calculator, doink, 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 you end up with 63 squared centimetres for the area of this lovely triangle. Woo! And for the geeky people amongst you, yes, sine 30 is a half, so you could work that out without a calculator. Half the 18, half the 14, times them together, and Bob is your auntie's uncle. Woo! Here we go. Example 2. Calculate the area of this triangle. We've got 107 degrees here, so we know the angle and we know the two sides, either side of the angle. So if we know an angle and the two sides either side of it, then we can use that formula. Area equals a half AB sine C. I'm hoping that you will know now that A and B are just going to be the two sides. It does not matter which one is which. And C is going to be the angle. So the angle has to be that 107. You don't even have to label them the way I'm doing it here. Just the area is a half times by A and B are the 5 and the 11. Again, it doesn't matter which way around you have them. Multiplied by sine C. And C is the angle, which is 107 degrees. So write down the formula, show you know how what you're doing. Then put in the numbers. And if you stick that in your calculator, you end up with 26.30 squared meters to a couple of decimal places. Either do it to 1 or 2 decimal places. Example 3, calculate the area of this yellow triangle. So, this time here we have the 40 degrees. And we know either side of the 40, we've got 131 and 74, but we also know this side across from it. We know this side is 88. So, what do we do?
Well, I think you would just do the 74 times the 131 times the 88 times sine 40 and half it.
No, that is not what you do. If you look at your formula, it is a half times A times B times sine C. So that's the formula we're using, which means a half is going to be a half. That's never going to change. But we need to think about what we actually need here. We've got sine C. C is the angle. What's the only angle we have here? 40. Good. So that there is going to be C, meaning across From C, we would have small c.
C for Camille.
Good. And we would have A and B.
A for Adam.
Yeah.
And B for Brian.
Good. So we'd have A, B, and C. Remember the A and the B, it doesn't matter which way around we have it. But if this is capital C, the side opposite that is small c. And if you look at the formula, it is a half AB sine C. We need A, so we would need the 74. We need B, we need the two sides either side of the angle. But do we need lowercase c? No, we don't. Sorry, Camille. So you can get rid of that. We don't need it. We just need the 131 and the 74. Again, it doesn't matter which way around you label these, as long as you've got the 131 and the 74 there, and you multiply that by sine C. And C was our angle, which was 40. Woo! From that, type that into your calculator, or just ask somebody really smart like Ariana, and you get 3115.59 squared meters. Ba-ba-ba-bum, to a couple of decimal places. Example 4, work out the area of this triangle. This one is slightly different because it's giving us the letters P, Q, and R. R. Good one there, Greg. Excellent. So, to work out the area of the triangle, once again, it is not a base and a perpendicular height. It's where we've got two sides and the angle between them. So, we're wanting to think about this amazing wee formula. Half AB sine C. So, we can write down the area equals a half AB sine C. What they're doing in the question. What I'm doing is I'm trying to confuse you. I'm giving you P, Q, and R.
Oh, don't be silly. You don't need that. Just ignore the letters.
Exactly, yes. A lot of the time in the exam, they will give you letters to try and confuse you that are different from A, B, and C. Ignore the letters completely. You don't need them. Because what you know by now is the area is a half AB sine C. C is the only angle in that formula. And if you look at this triangle, this here, the 120, is the only angle. Meaning that angle there would be C. So across from that would be small c. And then A and B are going to be the other two sides. And again, it doesn't matter which is which. So if you're putting in your numbers for the next line, if you sub them in, you would have a half times by A and B are the 5 and the 6. So it's a half times 5 times 6, or half times 6 times 5, times by sine of the angle. And the angle is 120. Good. So from there, once again, use your calculator. And you get 12.99 squared centimeters. Yeah. Ready for another one?
Oh, yes, please.
Okay, Derek, let's go. Example 5, work out the area of this triangle here. So, Maha, what do you think you do?
I think you have more information than you need here.
You're perfectly right, yes.
First of all, the angles are not A, B, and C, and they're going to try and confuse you, so ignore them.
Good, ignore the letters that they're giving you. Ignore the L and the J, K. Ignore them completely. We know the area of a triangle is a half AB sine C. And again, sine C, C is the only angle, and the only angle here is the 41 degrees. So, we know this angle is going to be C, meaning across from that, if you think about the last lesson with labeling the sides and the angles, that side has to be a lowercase c. So C is going to be 29. So the A and the B are going to be the 22 and the 38. Again, it doesn't matter which way around, you put the A and the B. If we think about the formula, area is a half AB sine C. You would have a half times by A and B are going to be the 22 and the 38. Remember, it doesn't matter which way you round. Remember, it doesn't matter which way around you have them, as long as you've got the 22 and the 38. But the 29, do we need that 29?
No, they're trying to confuse us. Don't let them confuse us. Ignore them.
Exactly. We don't need that. We don't need C. We just need a half of A times B times sine C. And sine C is going to be the sine of 41. Good. Type that into the calculator.
Doink, 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 doink. Doink, 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 doink. Doink, 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 doink. Doink.
Yes, 274.23 squared kilometers to a couple of decimal places. Woo! Do you want another one? Let's do it. Next one, example 6. Calculate the area of this lovely shade of blue.
No, it's a bit peely willy.
It does indeed. Triangle. So we've got 36 degrees here. We've got 52 degrees here. We know this is 7 and we know this is 13. What do we do?
Well, we don't have the base and the perpendicular height, so we need to use half AB sine C.
We do indeed, half AB sine C. Remember here we've got C. C is the only angle in our formula, but here we've got two angles in our triangle. And I suppose because we've got two angles, we could easily work out the third angle as well. You could add them together, take away from 180. So you could technically use any of these angles, but there is just one angle that would work with this question. What you need to do if you think about using a half AB sine C, A and B are going to be the sides, but C is the angle between those two sides. And if we're thinking about the sides, well, this side we don't actually know. But we know this side and we know this side, meaning then that these two sides would have to be A and B. And as I always say, it doesn't matter which way around you have A and B. So if this here was A, then it means that angle across from that would have to be capital A. That would be angle A. And if this side here is B, then across from that, this angle here that is unknown will be angle B. And it means then that 52 will be angle C. Good. Even if you got it the other way around, if you called this one the 13A, then that would be capital A. And if this here was B, then that would be capital B. Again, A and B would be these two angles, and 52, no matter which way you do it, will have to be C. So when we're thinking about half AB sine C, when we're looking for two sides and the angle between them, well, these are the two sides, the 7 and the 13, and the 52 is the angle between them. So we'd have a half times by A times B. Again, doesn't matter which way around you have it. You've got 7 times 13 or 13 times 7 multiplied by sine of the angle. So it's sine 52. Make sure you're not using the 36. It's two sides and the angle between them for a half AB sine C. If you type that into the calculator, splish splash, I was taking a bath, you would get 35.85 squared millimeters. Whoa, that's awesome. I know. Do you want to try another one? No! Okay, example 7, work out the area of this triangle. Once again, think about the formula, because we don't have a base and a perpendicular height, so we're thinking a half AB sine C. With this, C is going to be our angle and A and B are going to be the two sides, either side of the angle. With this question, don't start sticking your letters absolutely anywhere. Think about what the formula is all about. To use the area formula, it's a half AB sine C, so it's two sides and the angle between them. Again, it's two sides and the angle between them. So if we look at the sides, we only know this side and this side. We do not know this side here. So we'd have to be using these two sides. And if we're using those two sides, which angle would we use?
It's the angle between them.
It is. Well done, Fred. It's the angle between them. So that 80 and that 31 are not going to be used in our formula. It is this angle here because we'd have the two sides and the angle between them.
Oh, we've got a slight issue.
Yes, what is your issue, Tiffany?
We don't know that angle.
Yeah, you're right. Kyra, could you help us out though? How would you find that angle?
I don't know.
Somebody else? Kaylee, how could you find that angle?
Well, there are two sides of the triangle, so you can add them together and then take away from 180.
Yeah, well done. You could work out the size of this included angle. Remember, the included angle is the angle that's between the two sides, you know? So you can work that out by doing 180 minus the sum of the 180 minus the 80 plus the 31. So add the 80 and the 31 together, take away from 180, and you get 69 degrees, meaning this angle up here will be 69 degrees. Woo! So, when we're then using the formula half AB sine C, we'd have A and B as the 19 and the 15. So it's going to be a half times the 15 and 19 times by sine of the angle. And the angle is, say it with me, 69! Woo! Type that into the calculator. Down, 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 down. And you get 133.04 squared meters. Yeah, high five, people. Example 8, let's move on to a slightly trickier question. Work out the area of this parallelogram. Can you say it, Rejwan? Parallelogram? Not bad, well done. So, working out the area of this, how do we do it? Hold up! What is wrong? Zaid? Yes, you're right, that is not a triangle, it is a parallelogram. And you're right, yes, this is all to do with working out the area of a triangle, but this is a problem-solving question. We are not told the area of a parallelogram, we don't have a formula for that. What are we going to do? Yeah, well done, Matt V, you're right, you could split this shape up if you draw a line across that diagonal. Woo! To here. Well, really, what we've got down here is a triangle. So we would just have that triangle that looks something like that. And we know if we're splitting it up across this diagonal, this triangle at the bottom is the same as that triangle at the top. How does that help us? Well, yeah, first of all, the opposite sides in a parallelogram are equal, so that would also be 58. And if the 44 is there, that will also be 44. So really what we've got is we've got this triangle at the bottom. We know that's going to be a 127. We know that. We know this side is going to be 44 because it's the same as the left-hand side. And we know the bottom there is going to be 58. So really what we've done is we've got that triangle where we've got two sides and the angle between them. And if we know this triangle here at the bottom is the same as this triangle here at the top, well, to get the area of the parallelogram, we could just do the half AB sine C for the area of one of the triangles and then double it. So half AB sine C and then times by 2. And yep, for those smarty pants amongst you, really the half and the times 2 would cancel out, so you could just AB sine C. But for anybody that just wants all the steps, just going from that, you could do it half times by, and again, two sides and the angle between them. We know this is 127, so we'd have sine 127. And the two sides would be the 58 and the 44. Two sides and the angle between them. So it's a half times 44 times 58 times sine of our angle. But again, that's just going to be for one triangle, so double that times by 2. And if you put that into the calculator, that ends up giving you... yeah, 2038.12 squared meters to 2 decimal places.
That wasn't so bad.
Good. And final example, this one here is common in the exam. They're always liking these wee sneaky questions. So, example 9, the top of a table is in the shape of a regular hexagon. The three diagonals are shown as dotted lines, and each diagonal has a length, wee, of 50 centimeters. Wee, wee. So we know each of these lines is 50 centimeters. Work out the area of the tabletop. How do we go about doing that?
I don't know.
Well, think about this. If you're drawing in the diagonals, you end up with something that looks like this. And what shapes do you end up with if you draw in the diagonals?
Oh, I see.
Go on then, Sam.
Oh, you got 6 triangles.
You do indeed, yeah, you get 6 triangles. And if you think about this, well, for the triangles, we don't know what the length of this side is. We don't know that. We don't know that side. We don't know that side. You probably work them out. But you know the diagonals as well. What's the length of the diagonal, this dotted line from down here to up here? What is that length, Mohammed? Good, it is 50, yes. Which means then from here to the centre is going to be 25. Good, so we know that side there on this single triangle will be 25, and we know this side here will also be 25 because it's a regular hexagon. All the sides are the same and all the angles are the same as well. So that's 25, that's going to be 25. How would you get that angle though? Because in order to work out the area of, say, that triangle, half AB sine C, it's when you've got the two sides and the angle between them. How could you get that angle? Does anybody know? Lewis, what are you thinking?
Well, because all of the triangles are identical and there's 6 of them there, if you went right the way around, that would be going around 360 degrees. So just divide that by 6.
Perfect, yeah. So if you do 360 divided by 6, it gives you a triangle. If you take one of these triangles, it gives you a triangle that looks just like that, where half of that dotted line just takes you to the centre, so that'll be 25. This would also be 25 as well, 25 and 25. And yes, the angle for one of the triangles will be 60 degrees. Very well done, good. Because those 6 triangles, you'd have 60, 60, 60, 60, 60, and 60, which would make that 360 degrees. Good. 360 divided by 6 will give you 60. Perfect. How does that help us then? Good. All you have to do is work out the area of one of these triangles to begin with. Well, let's do that. So the area of one of the triangles would be half AB sine C. So it's going to be a half of, and again, think about this. Half AB sine CC is going to be this angle, and A and B will be the two sides, either side of it. So it's going to be a half times by the 25, times by 25 again, times sine 60. And if you put that into the calculator, you get 270.6329 to a few decimal places. Don't just round it to one decimal place yet, because we're not finished the question. If it's not your final answer, don't round it to 1 or 2 decimal places. Keep it a wee bit more accurate, and make sure you keep it really accurate on your calculator. What we've done is we've worked out the area of one of these triangles then. Jamie, what do we do next if we know the area of one of the triangles?
Well, because there's 6 triangles, could you just times it by 6? Because those 6 triangles make up the hexagon.
Yeah, you're perfectly right. So the total area will be the 270.6329 blah, 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 blah. Again, on the calculator, multiplied by 6. Well done, Jamie. And if you type that into the calculator, you get 1,623.8. That's just one decimal place, squared centimetres. So that will be the area of the tabletop. Woo! Yeah! As I said, that question is very popular in the exams. If you're feeling quite confident with some of these questions, the area of a triangle, give them a shot just in the TJ National 5 book, page 73 to 75, exercise 8.2, or any other textbook you like. Zeta Maths is normally quite good as well. It will have millions of questions, but you're just working out the area of the triangle using that formula there, half AB sine C. If you are very, very confident and you have practiced it, move on to the next lesson where I'm giving you the area, but I'm not going to give you a side, or I'm not going to give you an angle, and you have to work backwards to get that. Oh, that sounds a bit more challenging. It is indeed, but perfect this first of all. Good luck. See you later. So long. Farewell. Bye.